Hello, everyone. My name is Anthony Kazoob. I'm the chair of the Toronto Audio Engineering Society until January 1st. We then hand over the chair to Ross Whitney, who will be taking the position on with the support of the Toronto executive. So look forward to next month and next season, next year. It's been an interesting year, to say the least, in terms of COVID and the pandemic and everybody's work situation. And this recap that we're going to have tonight is a bit of a jump around between some of the shows about techniques, some of our days in the Twilight Zone, some of our immersive content, some of our escapes, and some of our really, involvement with our community. The Toronto Audio Engineering Society is really a community of audio engineers who come together to really disseminate information and network together. So sit back, relax, enjoy tonight's presentation. If you enjoyed it, please, like, subscribe, share, and we'll see you at the next one. Take care.
Here are 5 steps to making homemade reverb. Step 1. Find a suitable stairwell. The CBC has lots of giant stairwells like this one, but any enclosed stairwell will do. Step 2. Place a speaker at the bottom of the stairwell. Get it off the floor, maybe set it on a chair or a piano bench. Step 3. Place a microphone on a step. Lower steps will make for a shorter reverb time. Higher steps will make for a longer reverb time. Step 4. Send dry, unreverberant sound to the speaker via an aux send on your console or DAW. Step 5. Mix the microphone sound back in with the dry signal. Voila! A totally unique, one-of-a-kind reverb. If you like this video or have a suggestion for the next one, let me know in the comments. And don't forget to subscribe.
Thank you for attending our event. The Toronto AES unites engineers socially. Within our allied arts, we collate, collect, and disseminate scientific knowledge that furthers all fields of audio engineering. The AES aims to empower people of all ages through participation in a healthy, safe, open community presentation. Learn audio engineering through events, presentations, networking, and mentorship. For more information, go to torontoaes.org. There you'll find over 30 years of meetings, events, Masters of Audio, members showcases, and much more. Our sponsors are the Solotech, Gear Audio, Sono Technique, Bell Media, YSL Pro, Electrosonics Canada, BRTB, Global USS, Adamson, Lawo, avshop.ca, and Q5X. Give the gift of membership. Go to aes.org/join to join today.
Howdy, my name is Heather Kirby, and I'm a mastering engineer and audio educator, and I was invited by Toronto AES to participate in their panel Audio in the Twilight Zone. So here I am, just wanted to share a little bit about my experience of working through the pandemic, adapting to a new space, some of the challenges that have come out of working remotely, and to introduce you to my studio, Dreamlands Mastering. So this is it, and here we go. So before the start of the pandemic, I had a different studio that I was sharing with a friend in town in Picton. And so I was doing most of my mastering work there. And then I was also commuting into Toronto to teach at RTA School of Media. So I teach a number of studio-based courses for the school and have been teaching there for a number of years. When the pandemic hit, we were sort of forced to leave our shared studio space, or it just became too complicated to stay there and share the space. So we decided to leave. So I had to come up with another plan, obviously. I'm fortunate to live in a pretty rural environment, and I have a detached garage on my property. So we decided to just convert that detached garage into my new studio space. So, I mean, that was quite a process, thinking about what I wanted the room to be. So it's primarily my mastering space, but as you can see, I've also got a lot of instruments in here. I do some creative work in here. I do some engineering as well. So I wanted the space to be a little bit configurable so that I could easily kind of put the instruments away, move around some sound treatment and optimize it for mastering, or sort of pull the instruments out and use it as a full-on kind of creative space, or do some recording in here as well. So I was trying to figure out the best way to make all of that work. I was working with this existing dimensions of the structure of the building, and then, existing window spaces and everything else, and then kind of thinking of dimensions for the interior of the space that would work best for acoustics and so on. So it took a lot of research on how to plan out finishing the inside of the room. We did double walls just to help with sound. There's no one around to hear me and what I'm doing, but, without the double walls and some sound treatment, I'd probably hear a lot of woodpeckers or, cows across the way. So yeah, went with double walls to also get a nice cozy environment in the winter. Put up some really thick floor-to-ceiling bass trapping in all the corners, and then a number of other acoustic panels and absorbers around the room that, again, can be sort of easily taken off and moved around. Now that this is my space, I spend loads of time in here, and the nice thing about it is I'm just getting really familiar with the room the more I'm in here, obviously. I'm still doing a bit of fine tuning. I do a lot of sort of room measurements, moving speakers around, the height of speakers, the placement of speakers, some sound treatments, doing different measurements to make sure I've got things in the best place possible, given like the type of room that I'm using. So and in general, it's been really great having this new space, comfortable to work from. Actually, one of the biggest problems I encountered through this and converting, out of my studio space in town and to this new space was the internet. Because I'm in a rural area, we didn't have adequate internet at first, and it took quite a bit of sort of coercing a technology company in the area to come and get us hooked up. And so that was a bit of a process, and now that's all working out, which is great. So I managed to get the studio put together, pick up my mastering work, and have it all and the internet set up all in time also to start teaching last fall when courses were moved fully online. So in terms of like workflow with mastering, there hasn't been any huge changes in workflow because most of my work is unattended. I work remotely with clients primarily, so they're transferring me files. I do the work, I transfer it back, and we just have a bit of a back and forth that way. So not a huge workflow change for mastering. When I do recording in here, so I do a bit of engineering as well. I've found the Audio Movers plugin to be really handy. So I can send sort of low latency, high quality audio to someone else to monitor back what I'm doing in here. So that workflow has been, worked pretty well for me so far. I'd say the bigger challenges came in with teaching rather than my mastering work. So again, I teach at RTA School of Media, and the courses that I teach are often studio based, and one of them in particular is mostly in the studio, and I've got 30 plus students to work with. So in one way, I was very fortunate to have this new space for demonstrations. I can demonstrate multi-track recording in here really easily, and move my camera around and show the details of the gear and equipment that they would have seen if they were in the studio space at the school. So that's handy, but it's not, there's still the limitations of the students actually being able to physically touch and have the hands-on experience, which I think is pretty important for this specific course anyways. So anyways, I'd say there's sort of 3 unique challenges that came up while I was teaching, and that really sort of was a challenge to workflow and involved some problem solving. The first one is to do with accessibility. So teaching online, you have to recognize that every student's in a very unique situation. So they're in a different home environment. They may or may not have access to a personal computer to use during your live class time. They might not have a quiet, noise-free environment to participate live during classes either. They might be in a different time zone as well. So there's these different considerations you have to make. And so the approach was to deliver material live so students can tune in and participate synchronously, or participate asynchronously. So everything would get recorded, packaged up, and students could access the material on their own time when it's convenient for them. So one of the challenges we ran into with that was, delivering most of our classes on Zoom, and you can send stereo audio through Zoom, but you cannot record stereo audio with Zoom, which is like a weird, just like technical issue. You couldn't at the time. I'm not sure if there's been any improvements to it since then, but you could send stereo audio. You couldn't record with stereo audio. So running Zoom classes, trying to teach studio-based audio production, you want to be able to send stereo sound out. So there ended up being a bit of, record stereo sound and enable students to listen back in stereo, especially as you're discussing stereo field, panning, etc. So that was a unique challenge. Sometimes it involved recording everything that we were doing in class to a DAW at the same time in stereo, and then having to relink the audio with the Zoom feed and packaging it up that way. In more extreme circumstances. But certainly that accessibility feature, making sure the technology worked and that the goals and outcomes, learning outcomes of each class were being able to be presented to all the students in an accessible way and in a way that is true to what we're looking for sonically. So, in stereo. So that was one sort of technical challenge. Another challenge was to do with home studio support. So part of the course was to get students more familiar with studio recording. So we did this by setting them up, and there's a whole kind of technical team with RTA School of Media that helped coordinate this and did a lot of the troubleshooting as well. But it was to get home studio set up to all the students in our class. So making sure that they had a Pro Tools license, recommending microphones that they could get, either USB microphones or a microphone plus interface. And of course, and some are on Windows, some are on Mac. So there's different operating systems, different, drivers that are required to make this all work. And so, of course, there's a lot of troubleshooting that had to happen. So one of the ways around this was for the school to put together kind of a live tech support team. And of course, as a teacher, was a big tech support for students as well. But it was definitely one of those challenges where every student's setup is completely different because you don't know exactly what gear they bought, what system they're working with, and so on. So that was another sort of unique challenge that came about with this adapted version of a studio-based course. And then another sort of important consideration that came up on the teaching front was adapting actual student work and assignments to make them possible and accessible to students in this virtual environment, in this remote environment. So, there's projects like a music production project that typically would be group work in an actual studio context, bringing in a band and recording them and producing them. And it took a lot of sort of reimagining how to make this work in an environment where everyone's a bit more isolated or completely isolated, how to support them in where they're coming into the course in terms of musical background, how comfortable they are with their recording gear, and whether they are comfortable working independently or if they want to collaborate. So there was a lot of sort of just re-envisioning what the certain assignments would look like outside of a, physical studio context when we're all there together, and into this world where everyone's situation is unique. So it just involved being a lot more flexible in the design of assignments to make sure that everyone can participate, to make sure that people who are excited to collaborate with other students could still do that in some way. And those who, are more isolated and maybe don't have the same background in music, for example, could still pull off these assignments and learn a lot and meet the learning outcomes. So whether that was giving options on final delivery and what kind of format that looked like, or if it was being, giving the process, the pre-production process and the kind of creative process of how you get to the end product as much weight as the end product itself, or just kind of rebalancing the way that you consider these different elements in completing a project. So yeah, I'd say that those were the three biggest challenges to overcome in this new sort of remote environment that we were working in these courses I taught this past fall. So anyways, it's been a really interesting year, a lot of unique challenges, of course, a lot of adaptability, on adaptability for myself, a lot of lessons in how to adapt, and a lot of lessons on how to make a room that works for me, a lot of lessons on how to work with others remotely, how to support others in their own remote work, and also to, in the context of school environments, how to be understanding of everyone's individual situations. And it's, not the kind of work that necessarily is possible for everyone, and that's also okay because of the circumstances. But also it's been really interesting and amazing to witness the sort of adaptability and resiliency and creativity that has come out of a year like this, from, both with clients I'm working with and the incredible music projects I've been fortunate to master and to work on, and also from my students who have really sort of, done some really incredible work. So it's something I'm really happy about. So thank you again to the Toronto AES for having me, and take care.
For more information on the Toronto Audio Engineering Society, go to torontoaes.org. There you will find notifications on our upcoming events, past events, Masters of Audio, and our member showcase. The Toronto AES is brought to you by Solotech, Gare Audio, Sonotechnique, Bell Media, YSL Pro, Electrosonics Canada, BRTB, Global USS, Adamson, Lawo, avshop.ca, Q5X, and the executive team of the Toronto Audio Engineering Society. Fran, are you there? Are we synchronized?
I am. I did the clap. We're synchronized.
We got the clap. We're synchronized. Hey, fantastic! Thank you for joining the Toronto Audio Engineering Society for this meeting on noise.
Oh, I'm glad to be here.
Hey, cheers. What time zone are you in?
I'm Eastern Time Zone, Philadelphia. So right. We're time partners. We're pretty much, in the same. We're
vertically aligned. Yeah. I get that. Have you been jabbed?
Same longitude.
Are you? Have you been jabbed with the COVID shot yet, or?
Totally vaxxed. Actually, not only am I fully vaccinated, but I had my annual blood work done last week. My doctor tells me I got excellent antibodies. She complimented me on my COVID antibodies, so I'm 100% immune.
Hey, I enjoy that. That's I'm happy to hear that another a celebrity, cherished designer in the industry is all right. We've had a couple of people in our community community who've been affected by it, and it's good to see that you're continuing and you've gone forward with that. I appreciate that. Thank you.
You as well.
Your current time obsession is a YouTube empire. You were a designer. You've collected. You've done guitar pedals. Your pedals they're selling like NFTs in 2021. They're hot commodities. You're a tonesmith. You've created multiple different fuzz tones and you've reissued things. Fran, welcome to the Toronto Audio Engineering Societies.
Thanks for having me.
I am very interested in a conversation we just briefly had about reissuing chips and making chips behave over a period of a couple different dies. Could you tell us a little bit about how Frantone and FranLab became in your world?
Oh wow, we have more than a half an hour, right?
Let's do 15 minutes on this, and then we'll talk about noise. Weave in the noise as much as you can.
That's a long story.
Hey, cheers.
Frantone was sort of just a serendipitous thing. I was working for a guy who I was managing a rental business where I'm sure you have them up there too, where it's just sort of a place where you can rent everything from like party tables and popcorn machines to like jackhammers, and it's like anything you can think of, trucks and everything. We rented it, but I was managing his business, but he had come from an electronics manufacturing background. He was a long-time executive at Digital Equipment Corporation, and so he was there for the golden age of digital through developing hard drives and instant replay, stuff like that. So we talked a lot about electronics and stuff, and I was tinkering on the side just for my own use, and building little things I needed for doing recording and such. And I had tinkered together a little effects pedal on my own just because I needed one. And there was just some day came when we were having the conversation, and he was like, well, I'd really like to get into manufacturing again. And, he said, I don't care what it would be, just kind of a widget. I was like, well, what do you mean a widget? He said, it doesn't really matter what it is. I just want to make something. We were working at this, rental store every day, and at night we would be brainstorming about what could we do. We had some extra space in the shop and everything, and I thought, well, why don't we build a little manufacturing operation in here? So it was just kind of, we were just going to try building something. I said, well, I don't know if it'd be a good product, but I made this thing, and I brought in this little box I built, and I said, well, and he didn't know anything about effects pedals, but I explained, and we talked about it over the course of months, and we decided to do it. But we went down a path where, and I made videos about this, so with the long story, but we ended up making a prototype pedal that I thought was beautiful, but it was unmanufacturable. It was just the cost of making it would have been astronomical, and we really didn't have any means of.
Well, was it just too complicated inside? Too many parts?
It was a custom cast aluminum case.
Oh wow!
It was custom electronics. Almost everything had to be made. It was flocked, so it was a kind of a fuzzy pink pedal, and I had developed my own flocking process. I had to learn how to flock things. And,
what the flock is flocking?
Flocking is, well, it's still done, but it used to be done a lot in toys and stuff. So if you bought a toy animal, it was made of plastic. Sometimes it'd be furry, and it would have like this kind of furry texture to it. And I actually didn't really know how they did it, but I kind of just had to experiment on how to flock things. And so I developed this process of being able to flock aluminum cases to be able to get the pink fuzzy, texture to the case. And we actually had plans that if we were going to mass produce this pedal, that we had to build a mass flocking machine. And I'm glad that we didn't do it because, the flocking it's basically like tiny little trimmings of cloth. Like if you could imagine like yarn cut to like, a millimeter long lengths, and then you just have like a vat full of that. I mean, it's like, the only thing I could have imagined is if we would have gone into production and I would have been running a flocking machine all day, I probably would have died of flock lung.
This is like boom polonitis. It's only only 2 or 3 people in the world kind of die of flock lung. Well, that's
yeah. It would have been. I would have been the first medical mystery solved. Flock lung. There you go. That we did an autopsy. The inside of the lungs were completely pink.
That's it turns out it was guitar pedals. Just obsessed with it. Was a texture again, but it wasn't even a tone texture problem. It was the outside texture.
It was completely superficial. Yeah, death by flocking.
So how many pedals have you designed? What in your repertoire?
I manufactured 20 different, give or take a couple pedals over the years, and I did a couple others for other people. There were a lot of prototypes that I didn't actually make into products, but I guess you could count them too. So maybe 30. But I also, when I was working for Electro-Harmonix, I made a box full of prototypes for EH that they never wanted to build, and I ended up not building them either. But I've still got a box of those pedals that do various things. So
working for EH, is that kind of like do a lot of people show up with a box full of prototypes and become the next pedal designer? What is the process working for a company like that, or trying to get your foot in a door in terms of a manufacturer that works at that level?
Well, I just moved to New York. I didn't have really didn't have any prospects for a job, but I basically just walked in. This was in '97. I just walked into their office, and the manager at the time, it was the hiring manager and plant manager. I just literally walked in, sat down with them, and they knew who I was. They knew my work, and they just hired me on the spot. So it really wasn't a lot of negotiation. It was just the fact that I had been making pedals for a number of years, and that the Frantone line had enough of a reputation that they just hired me on. So that was my CV. The prototypes, I built them there because a lot of times I was bored, but I had this little shop in my apartment, my tiny little apartment, where I could tinker together things, and I was always working on new designs and trying them out, and bringing them in and saying, "Hey, do you want to build this?" And they'd try it out, and they'd go, "It's not really EH or whatever." And so I still do have a pile that I had built. So you're okay. So you're talking about a noise shape, and you're talking about a character shape, and you're talking about a tone shape. So let's talk about that. What is it in these things, and what is it that gives us this lovely other side of noise that is like a craved thing? What is it about the electronics? Years ago, I was in radio for a long time before I did Frantone, and before I had that job that led me to Frantone. I was actually a professional radio DJ, and what I learned in the radio business was that the little trick, sonic trick, was that it was long believed and sort of discovered in the industry that the human ear prefers to hear a little bit of distortion rather than like pure tones. So in the processing, on radio, making the sound of the record or the CD a little nonlinear, a little distortion, it makes people perk up a little bit. People want to hear it. They prefer hearing a sound that has a little bit of distortion in it, and it's something to do with the way harmonics work, but it's more pleasing than the pure tones. So there's something fundamental about the human audio processing that we have in our brains that makes it desirable to hear distortion, to hear noise. It's sort of akin to spicy food. It sort of defies logic that we would want to eat chili peppers.
Right.
But we do. There's something in our brain that makes that, desirable. But there's something about noise that also has. So with finding like good tone, it's always riding a very fine line between pleasant distortion and unpleasant distortion. But the certain amount of nonlinearity does make sound more edible to the mind.
Let's back that up. Okay, when you say nonlinearity, so
Right.
let's break down because you can talk about voltage, time, frequency. You can talk about nonlinearity. So when you say nonlinearity, in what way are you manipulating it, and what way is it important in the tone creation that you're after?
Well, there's lots of things that can be defined as nonlinear. If you have a pure sine wave into a device, if you get that exact pure sine wave out, regardless of its amplitude, if it has exactly the same characteristics in the waveform, then by definition you have linearity. So a linear amplifier is going to reproduce that sound without changing the characteristics of the waveform itself. It might amplify it, but the amplified waveform you get out is going to be essentially an exact carbon copy of what it was seeing on the front end. And that's really the definition of linearity. So when things go nonlinear, they can go in lots of different ways. You can have tonal distortion. You can have phase shifting. You can have signal compression, where you basically are just kind of squishing the amplitude. All these things are nonlinearity. And to a certain degree, having combinations of these effects really is the essence of audio processing and effects. That's really what we're doing. Mm-hmm. We're manipulating time, phase, tone, and various harmonics and audio compression. But these are the things that sort of come together. We can mix them up in different ways. But all these things are nonlinearities, and each of them have their own sort of pleasing tastes and sort of flavors, if you will.
Mm-hmm. And these are the tricks, the ways that you trick these nonlinear characteristics out of components and signals that are passing through them are very important. So
yeah.
So because they're tricks, none of these things are in data sheets. You're asking components to behave outside of their normal operating conditions. Right. How do you characterize this though? How do you make it do the trick you want it to do?
Trial and error. I think that if you're exploiting a facet of a device that's outside of its design characteristics, it's really a matter of just setting it up, punishing it, and seeing what happens. That's sort of what I was doing with the LM386. But other times it's a matter of really trying to operate within the specs or pushing the limits of the specs. Like with the Vibutron, I was using a frequency generator that was really supposed to operate at 18 volts. And I wanted to make it run with a 9-volt pedal, which was really outside of its operational specifications. But I had to come up with ways to filter out the chips that I got to select ones that would work within my specs. So I learned that they had a kind of a wide latitude of operational tolerance in the signal generator. And so it was the 8038 CPD. And so I basically would order a bunch of chips, and I had a bench set up where I would have, a sine wave in, and I could measure the distortion and everything and the amplitude and various waveforms. And I just plugged the chip in, and then I could put it through all kinds of different tests, and I would look for the linearity and make sure that I got the right frequency range and everything out of it. And if it passed, my specs, then that went into a bin that would go into a pedal. And if it didn't, then it would go into a bin, would go into another pedal that I was making that would run at a much higher voltage, and it wouldn't matter about that. So there are also tricks you have to do to kind of work outside of the specs to get a component to operate within the specs that you want, not necessarily what's in the data sheet. Because there is a lot of latitude you'll find in those kind of specifications, especially like with operational voltage, output, the kind of output you can get from amplifiers and such, and the kind of frequency ranges that amplifiers will work in. So you can push it, but by being selective, because there's always a certain number of dies when they're making these chips. There's certain tolerances, and so depending on how they're making up the dies, with the process, some batches are going to work in certain parameters and others won't. So every now and then you get lucky and you'll get a batch of chips that'll work really great at either a lower voltage or a higher frequency or whatever. And you kind of seek out to find lots that are, going to be for just in the right tolerance band for what you need. So it's a combination of finding out what a chip can do, and then if you're pushing the limits, being very selective and just trying to find the freak prints that are etched outside of the design parameters that the manufacturer is saying it'll do. So it's both sides.
Interesting. So my curiosity then is, like, as a guitar pedal manufacturer, people call you, it's noisy. People call you, I blew it up. People call you, hey, it's I operated it outside your spec. Hey, I put 18 volts AC into this thing. Yeah. What kind of protectionism? What kind of circuit protection do you have to build into these pedals to buffer the outside, the unknown before you and the unknown after you, to be as low noise as you possibly can? Because these are just amplifiers, like you say, about to take off.
Yeah, it's a very good question. It's actually pretty tricky. There's two ends of it. There's the audio side, like you said, like audio distortion and stuff, and you want to have the effect work a certain way, but also there's the power side and the interface. So you have interfacing issues with it because you have to design an effect with the idea that's going to be working in coordination with other equipment. See, in the early days when I started out, I really didn't know any of the industry standards, which there weren't that many for effects pedals in the 90s. But when I started making effects pedals, I wasn't given any thought to the idea that my pedals would be in chains of other pedals or hooked up to pedal boards and have to interact, with in a pedal environment. And
systems, yeah.
Right. So the early designs, I didn't have any input buffering or anything on the audio chain. And it sounded great, actually, with having really no input buffering at all. Going right into LM386, the early Hepcats, I thought they sounded really crisp, and they sounded great. But early on, people were blowing them up, working them in pedal chains where just static discharges and stuff would be taking out the first chip. So I very quickly learned that you have to design an effect to sort of be like an iron box. You have to protect it on all sides. So you have to have input buffering, you have to have output buffering, and you have to have power buffering so that no matter what people will plug into it, it won't catch fire. And finding ways to do that would preserve the characteristics that you want was tricky. Input and output buffering for the audio is pretty straightforward. You end up having capacitors to buffer the inputs and outputs from DC, because a lot of effects chains have pedals with active switching, especially some of the older ones, and they would have DC offsets on the audio line quite often. And so if you have a true bypass pedal after a pedal that has active, transistorized switching, often you'll have a little bit of a DC offset, and it could be like a fraction of a volt, 0.7 volts or 0.8 volts or something, or like a diode drop of DC above ground. And when you have an actual physical switching the audio chain, and you've got a little DC offset, you end up with the switch pop. Ooh. And so that ended up being a big problem.
The thumping noise. The thumping noise. So the thumping noise you're saying is like a DC leakage,
DC offset. Yeah,
Okay,
It's
so
because when the contacts make and break, if you've got a DC offset there, you're pulling current when you break the connection. So and that gives an audible ponk when you flip the switch. So, but that's a very common issue with mixing true bypass and active switching pedals. Not so much nowadays with pedal boards, because pedal board manufacturers are sort of caught up with that. So usually they have like active switching pedals, like isolated with like a true bypass, like their own little circuit and stuff. But in the early days, it was a problem. And with power, there was an evolution. I had an evolution with my input protection on the power. I used to have a passive crowbar, which I did with a Zener diode and like a 10 ohm power resistor. And it basically would just passively sit there without taking any power from the input. But if you put in too much voltage, the Zener would clamp and bring the voltage down. And if you flip the polarity, the Zener would basically act like a short and ground itself and self-destruct like a fuse to protect the circuit inside. But people were blowing up my crowbar, so I was replacing them and stuff. But when I came out with the reissues this time around, I went with an active crowbar using a PTC, or a positive thermal coefficient thermocouple. So with PTC,
so it heats up and cools
right.
down, and instead of a fuse.
Exactly. So with the PTC, instead of a resistor, the Zener diode, if you reverse the polarity, the PTC heats up really fast, and it just basically the resistance, because it's a positive thermal coefficient, as the heat goes up, the resistance goes up. So it basically just acts like an open and protect. So it's sort of like a very simple, cheap, resettable circuit breaker. But it works, but it protects against reverse polarity. But the advantage of doing that, rather than having the traditional diode in series, like just a power diode in series with the voltage, is that you don't have the voltage drop issue. Because if you want to have like 9 volts of headroom in the effect, like to get maximum performance, and some of my effects like the Vibratron stuff really have to have like 9 solid volts to perform. Shaving off that 0.7 volts or whatever, just having that diode, that's doing some serious compromise. So having the passive crowbar in there, it was a way of getting around losses, so I could maintain my 9 volts but still have protection.
So maintaining the signal to noise ratio, or the distortion potential ratio, I'm going to call it the distortion potential ratio in this case, is important to your design. So your pedal can perform to its maximum in its range.
Well, yeah, because some of the designs I ended up with the reissue of the Peach Fuzz, I ended up taking out the 386 third stage and replaced it with a rail-to-rail op amp. So with the rail-to-rail op amps, it will output to the VCC. So whatever your supply voltage is, it's not like you have a diode drop or a 1.5 volts below supply. You can actually get peak all the way up to top. So the difference in like a volt makes a difference in the performance, 10% or more.
Yeah, totally.
Difference in performance. So, so it makes a difference. Like I said, in things like the Vibratron, where I was already running, the chip out of spec, running 9 volts, running, 8.2 volts, it's like, no, then you're really pushing. So yeah, there were lots of reasons to have like the not only 9 volts like at the jack, but to have 9 volts like at the circuit.
You said something that struck very clear to this conversation about noise, and that's the fact that, like you said, it was an iron box, the shielding enclosure, the complete encasement of the amplifier. Why do you do that in your designs, and what are some things that people do wrong, and what's the secret behind that iron box and that shielding enclosure?
Well, there's the primary reason for the full metal enclosure is just isolation from radio noise, RF noise, and stuff. I learned, and that was another mistake when I made my original prototype for that effects pedal that we started Frantone with. I put it in a plastic box, and I actually demoed it like a few months ago. I did a video where I pulled it out and fired it up. It still played great, but it was like really noisy and hummy and stuff because it's in a plastic box. So there's absolutely no isolation from all of the radio noise, ambient noise from switching supplies and just the buzzing and clicking of everything that makes RF noise. So putting the enclosure, using an all like aluminum enclosure, you basically have a Faraday cage around the circuit. So as long as you have good grounding on the audio and power, then you've pretty much protected your electronics from external noise. But that doesn't mean that you don't have to deal with internal noise sources. That's a totally different issue. But it eliminates the external by having it in the enclosure.
So you say, what you seeing? Are you seeing a lot of equipment now that are made out of these plastic boxes, or is there something inside these plastic boxes, like a shield inside that they're doing?
No, I mean I think aluminum is sort of the standard. Everyone's using some form of die-cast aluminum box these days. Even the tiny ones are all metal. So I mean, there were some. I think Dane Electro and some had some plastic boxes. I imagine they'd have to have some kind of foil, inside or whatever. But if you go with plastic, because it's cheap, then you have to have that sort of cage around the electronics. But I think it's just bad design to have a plastic enclosure. Not the least of which is that it's breakable.
You're gonna get stepped on a million times. Like,
yeah, I used to in the early days, because when I started using the die cast, it was kind of unusual. Because in the 90s, when I thought of effects pedals, I was thinking of the EH pedals and stuff. They're all in those sort of folded metal
sheet
designs,
metal, yeah.
Sheet metal that you could drive it over with a car and just flatten it like a can. So I originally we were thinking that, well, it would be a great demonstration to get like a video camera, and because we were. The guy that I was working for, he had a plane. So I had this idea that I would take a hepcat and I would demonstrate it on the ground on video, and then we would go up in the plane and we'd fly around, like get up to like 1,500 feet over a field, and I'd drop the hepcat out the window, 1,500 foot drop into a field. We'd land in the field. I'd walk up to dig up the hepcat out of the ground or whatever, plug it in and play it.
It's rude not to. You got to do these things, and your guitar, like you've done a lot of guitar videos. You play in a band, you record stuff. Guitars are these magical things that always go into pedals, and one of the things is every guitar I've ever dealt with is a great antenna, and you're always feeding it into, like you say, amplifiers that are, borderline exploding. Why do guitars behave the way they do? And what are some things tried and tested? Maybe Fran's, we'll wrap up here with maybe like a tips and tricks for guitar players who have that buzz, hum, and rattle in their instruments.
Yeah, well, you said it. The guitar is a perfect antenna. I mean, it's you got a coil of wire in there. And you're taking that coil of wire and you're running it through another really long wire and putting it into an amplifier. So, single coil pickups are notoriously hummy. That's why the humbucker was invented, using two coils and using phasing and such to try and cancel out the very common noise that you get from the 60 or 50 hertz hum of the electrical equipment that comes from light fixtures and the amplifier itself and everything. That it's a common problem, and anybody who gets into music, if you're really not experienced in grounding and dealing with noise, if you get out and tour, the first thing you're going to encounter is that there's going to come a time when if you're playing a single coil pickup guitar, when you're going to get up on a stage and you plug it in and it's just humming and there's nothing, and you just can't find the thing. But there are lots of tricks. You start to learn about routing wires and such, like when you're running your patch cables and things, not to run a lot of cables in parallel. You don't want to be running your audio cables in parallel with power cables on the way to amplifiers and stuff. You try and crisscross, or cross paths of wires and stuff to avoid, inductance and things. And with pedals, because of the inherent problem with radio noise and picking up radio noise, it's very common in pedals to put an RF buffer, like an RF clamp, right in the beginning, so that anything above a certain frequency, like anything over 30K or 40K, is just cut off. You have a flattened off curve, so that it just any radio noise will be eliminated. But the problem is, at 60 hertz or 50 hertz, you really can't eliminate those frequencies without affecting tone. So that it gets tricky. So the RF noise you can definitely cut out of the effect, but the power line noise it's always an issue. That's why their whole industry is built around equipment racks that will deal with hum, or phase cancellation. Introducing a 60 hertz hum that's out of phase, and you can adjust the phase so you can basically cancel out the hum rather than eliminating it from the front. You can actually introduce a 60 hertz hum and just kind of dial in a phase cancellation and adjust the amplitude and take it out. But yeah, there's lots of tricks, but it's always a problem. Noise.
So what's next for Fran Lab? Can you tell people about the website, how to get in touch, how to check out the channel, how to become a fan and like and subscribe?
Well, it's if you just go to their YouTubes and type Fran Lab as one word, it'll come up. But it's always something. I've got tons and tons of stuff in there, boxes and boxes of things. I got stuff on the bench right now. I've got some new unobtainium, some stuff people sent in I've got to fire up. So it's that's
the one thing about your channel. Yeah, it's like really rare one-off electronics. I found
it's sort of my collection is becoming more and more very rare and obscure things, and people send stuff in that I hadn't heard of. So as many things as I find myself, other people find things and send it in. And
have you got something on the bench? Can you show us one thing before we take off here?
Well, the bench is way over there.
Oh, it's way over there? Okay. Never mind then.
I'm wired up here.
You're wired up. Okay.
So,
all right.
Yeah, this is the other side of the lab. This is all the this is the storage part of the lab. You can probably see behind me various storage boxes and such. But yeah, it'll come up. I don't like to reveal what's on the bench until it's ready.
I get that.
But it'll come around. Yeah, definitely.
All right, Fran, thank you so very much for your time.
Thank you.
We'll have you back again sometime. It was a fantastic chat. Thank you for all your information.
Yeah, I'm looking forward to coming back to Toronto.
Hey, yeah. We'll see you soon.
See ya.
Okay, I've snuck into the candy store for the Audio Engineering Society, and behind these new doors are the collection of CBC microphones. And if you look here, we've got some standards. What is this? Beta 58s. Look at this. Okay, 46s. These are all production microphones. A lot of Sony stuff. Some of the radio stuff is mixed in here. So this is Sanken, stereo Neumanns. Okay, hold on. Let's pick one to open up here. Oh my gosh. Okay, all right. And these are not rock and rolled. These are all like, classical, right? They're treated with respect. Look, so in here there's a stereo set and the microphone and all of its associated wires and everything. All right, let's see what else. I gotta put this aside. I'll put it away later. I promise. There's like the classic, just in case Obama visits, you got the 57 cover. You got all the accessories. Look at this. It's just so beautiful. It's like an archive. Under the B, you got the 4006. You got 714s. You got 4011s. What else you got here? 416s. All the widgets for the 416s. Oh my God, it keeps going. Okay, so here's B&K 4011s. Oh, it's the back side. All right, okay, let's go. Let's keep going. All right, slowly. Don't spill them. Don't spill. Okay, shh. Okay, up here, got the Sonys. So some Studers, Seducers, 414s, of course, 450, 535s, classics. What do we got here? D12s, of course. Look at all the 451s. Nikes. Holy. So this is Tube. This is AKG, the Tube. Those are super duper. And then over here, Yamaha MZs, Coles, ribbons, realistic PZMs, crowns, 86s, 83s, 84s. Holy. 105s. It's like a store. Like I say, it's a candy store for producers, engineers. When they have a project, they're just like, okay, take what you want. A bunch of 47s. Oh, sorry, these are 87s. Let's take a look. So these are just on the shelf. So, And then some studios have their own archive. They have their own collections. What's here? 147, the Tube. Oh. Dun, dun, dun. I have to look it up. All right, there he is. There it is. Look at that. I don't know what version this is. Let's take a look. So this is old. This is, doesn't even say. The head. 422s? What's a 422? Sorry, I'll put that away. I promise, I'll put it away. Shh, not supposed to be here. That's not true. I got permission. All right, let's take a look. So, stereo, I think that's the stereo. And you can change the pattern on it. So a lot of this stuff, like I say, not rock and rolled, very, classical recording engineers. That was a lot of the stuff, a lot of the microphones out of the Glenn Gould, a lot of the radio studios, Geffels. What else they got? Okay, here. But wait, there's more. Look at this. And then all the widgets, for like day-to-day productions, all kept down here. What do we got? So over here's piano kits. Some special. Oh, jeez. Some chefs. Oh my gosh, what is this? I don't even know what this is, but I gotta open it, Tom. It's like miscellaneous. Oh, almost opened it. Oh, what is this? I don't even know. Look at that. It's a Studer. Some of the stuff is antique-y, like this. This is very antique-y. But beautiful sounding probably. Probably just sounds amazing. And some mics that I've never seen before. Sometimes CBC would get prototype mics. SM98 drum kit, rock mic kit, DPA rock mic kit. What's this? So it's all the little teeny tiny DPAs. What's in a clip kit. All right, I gotta get out of here before they they think I'm insane. Every time I come down here, I give this tour. And they're like, what is wrong with you, Anthony? And I'm like, I think everything is wrong with audio folks because when they see this stuff, they just love it. And everybody's a collector, and the CBC is no different. That's for sure.
For more information on the Toronto Audio Engineering Society, go to torontoaes.org. There you will find notifications on our upcoming events, past events, Masters of Audio, and our member showcase. The Toronto AES is brought to you by Solotech, Gare Audio, Sonotechnique, Bell Media, YSL Pro, Electrosonics Canada, BRTB, Global USS, Adamson, Lawo, avshop.ca, Q5X, and the executive team of the Toronto Audio Engineering Society.
Good evening, everybody. Thanks for coming out and joining us on our meeting or event, however you like to call it, on hearing and audiology. I'm Mariana Hutton, and I'll be interviewing and introducing some of our guests tonight, which are very knowledgeable individuals in research and practice of hearing and audiology. So, make sure you put your headphones on and let's enjoy the show. So, Jeremy, would you like to introduce yourself and your area of research and expertise for our audience?
With pleasure. My name is Jérémy Voix. I'm a full professor at the École de Technologie Supérieure in Montreal. So I've been a trained physicist and really had a passion for acoustics, since my teenage years. So it's been a while, and I'm now really specialized in mostly hearing protection, so hearing conservation, and working on advanced hearing conservation solutions and things like wearable and hearables.
Interesting, very, very interesting. So the first question that I have for you this evening is, now due to stay-at-home orders, engineers have had to move some of their setup to be able to work from home. This often entails working in apartments without speakers. What are the effects of working on headphones over a long period of time? How can we mitigate these effects? Are there other types of quiet listening that would be less damaging to hearing?
Okay, so the less damaging to hearing, statement is a little bit of odd things for me, because there is a little bit of a maybe urban legend or myth that having something in the ear closer to the eardrum might be inducing more damage or risk of damaging the hearing. And there is absolutely no literature really citing this.
Oh.
There are a couple of very interesting pieces that I'd like to highlight for your folks that are in the audio aspect. So first to start, that what we call damage risk criteria, that are really those levels that you should not exceed, per the, let's say, occupational safety regulations. So let's say 85 dB for 8 hours. This is what a worker in Canada can be exposed to. And those levels are actually measured in free field at the center of the head without the human subjects being present. So this is really a free field recording. And this is how those damage risk criteria have been established. And we always relate to that value in free field equivalent. But the thing is that now, if at the same time you would be exposing that subject to that sound field and measuring inside the ear, you would see actually a much larger level in the ear canal because of this pinna effect. You understand that this is an amplifier, natural amplifier, it's a horn, and it does boost frequencies in the mid-range by up to 15 dB. So that's a huge amplification that now when you're listening actually on earphones, you would have indeed to listen and you will have to crank them up 15 dB louder than your normal speaker because of that natural, amplification that is happening in the pinna. So there is sometimes that confusion of what we call the free field correction aspect that is misunderstood for saying, well, those in-ear devices are really too loud and too dangerous. So that's one. There is another one which is a little bit much more subtle, but again, what we call the loudness, which is really the physical or psychophysical sensation of how loud something is. is actually a little bit related on what is providing the sound source. So if this is a loudspeaker, ear muffs as you do have, or in-ear device as I do have, for the same sound pressure level at the eardrum, the loudness might be different just because of some complicated but psychophysical artifacts, sometimes referred to as the missing 6 dB. Some people can go back in the archives of AES and find some discussion on that. And related on that, just another thing too is that when you're listening to speakers, you know that not only your ears are sensing those air vibrations, but your whole body, and you know that from your bodies and night experience that this is really a physical thing. So the fact that you're listening on earphones sometimes lead to the impression that you need to probably put more level in order to have that same feeling and comfort. So just to say that listening on earphones is not necessarily more dangerous, and you're not really at risk while listening at home on any personal devices. The only word of caution is obviously that if you have to listen for long hours, you should really make sure that you reduce the level. And you know that what matters is not so much the instantaneous level per se, but really what we call the dose, which is the duration times the level. So level times the duration. And now if you have to listen to loud levels, for whatever reason, mixing things and so on, well, do so, but make sure that this is reduced duration, because again, this is dose that matters. And that is the key to those dangerous levels. So on really what you can do in practice, there are more and more devices that will, in the near term, support that dose assessment. So again, level times time. And I'm referring to an initiative I'm part of, which is part of the World Health Organization, which is called Make Listening Safe. And this is really the initiative that all consultants, academics, manufacturers would gather around the table to define how we can actually assess that dose on your personal music player, PMP, and limit it. And you may see some devices that are coming nowadays, from Californian companies and so on, that do have some kind of indication, and there would be others coming up. So it's, getting some traction, and you will be able to assess for yourself how dangerous your listening experience has been or not.
Oh, that's great. That's great that that's coming up. Well, yeah, I mean, cell phones now already have you can set up a limit, right?
That's right. And you used to,
personal.
Even, 20 years ago, I remember in Europe having those AVLS, so automatic volume limiter systems that were very, very basic level limiters. But nowadays, the idea is really that you limit the dose. And more important than limiting, the idea is really to inform. So the analogy that I do with the dose is, let's say you're listening to a mix and you're on the airplane and you'll be landing in London soon. And the system will actually, monitor your current level and the cumulative dose that you had from your beginning of the flight, let's say, and we'll say, well, you know what, Marina, you'll be in 30 minutes, you'll be reaching your own 100% dose. So are you fine with this? Because that's in half an hour that it should shut you down. So if you're fine with this is fine. But if you're in the middle of your flight, maybe you'll just be turning your music down in order to increase that maximum duration, right?
Wow, that's really interesting. Yeah, I remember learning a bit of that when I was in audio school. I got educated on that. I was very, very lucky to have professors that cared about our hearing. We're teaching us about carrying, about getting audiograms and all that stuff. I was very fortunate. So the second question that I have for you is, what research has been done regarding recovering hearing loss? Has there been any progress regarding recuperating some ranges in hearing that have been lost? I've been hearing some pretty encouraging treatments regarding tinnitus. What findings can you share regarding that, if you have any?
Okay, so let's divide the hearing loss per se. There has been for real, and for a long time, real, attempts at finding therapeutics and drugs and treatments that would indeed help you recover some of hearing loss. So far, there are some promising, North American, Massachusetts-based companies that did range, I guess, phase 2 trials and trying to, inject in the middle ear some drugs that would actually alleviate some of your, noise-induced hearing loss. But again, this is important to mention that this is only for noise-induced hearing loss, not for the aging of the ear. the presbycusis that happens and cannot absolutely not be recovered yet. So that's the first limitation. Still, it's a long shot. There has been ups and downs. Things haven't been easy for them and other companies, as far as I know, and it's not there yet. And it's quite invasive. It's injection again in the middle ear, so it's not the simple pill that you take before going to gym clubs or whatever. And there has been as well on the other side, let's say, extreme side, so military personnel exposed to IED devices, so exploding and being completely blasted and so on, probably bleeding from the ears and so on. There are there are treatments that will exist that are really special cocktails with sort of steroids and the like, but they are really experimental, not there yet, and so nothing really to prevent noise-induced hearing loss as we speak. While we know that other species, birds and so on, can regenerate those outer hair cells, we do not as human beings yet. On the tinnitus side, this is interesting because indeed there was a lot of good news, I guess, during the last fall, with regard to, as I would say, two things. So one was a treatment that is now involving what is called neuromodulation, which is a bimodal neuromodulation. So you typically stimulate through electrical discharges on the tongue. At the same time, you're producing audio events. And this is an Irish-based company, I think, that has some preliminary results that are very promising. And there is still a need for some further validation, and real trials. There was also an interesting study from an Australian group, Bionics Hearing, that is dealing with the imaging of the tinnitus. So being really able to, because that tinnitus by definition is something that you hear, but that is not present in the environment. So you cannot record it, you cannot measure it, and nobody else can experience it. So how can you really see that it's affecting and is mapped on your auditory cortex? Well, using functional near-infrared spectroscopy, we can now see those effects, and this is obviously a big, I think, enabler for a lot of research coming up. And in terms of treatments, there are definitely, not that much treatments, unfortunately. I would say that, I can just recap the general understanding of a tinnitus nowadays is that basically this is, all your neurons and synapses that are just free gaming. So the idea is that if you have some hearing losses, that happens in some frequencies, and that the ear has what we call a tonotopic organization. So frequencies are mapped. So this is low, this is medium, this is high, and extremely high. And the idea is that if suddenly you have one fiber or one outer hair cell that is destroyed by hearing loss, so let's say the high frequency is missing, what will happen is that along the chain that goes to the brain, let's imagine my arm is my central auditory system. What will happen is that basically that all those neurons and synapses and nerves that are feeding that information to the cortex are free, and they have nothing to do. What they will do is basically free fire and send those tones that are really linked to the hearing loss. So now we understand that where you have hearing loss, you have tinnitus. And one of the ideas is actually what we call stimulation in the loss. And so one of the ideas is to send tones that are really aimed at those deaf parts of your body to realign them and give them some data to process and to treat and to avoid them to be, firing at random stage. So this is stimulation dans la perte. And that's one approach. The other approach are obviously the old thing of masking, those annoying sounds. Some of the, cognitive or I would say behavioral therapies and, living to learn with it and those kind of things. But I guess this is definitely one project we have on the stimulation of those dead zones, let's say. So.
That's very interesting. Yeah. So next question, will be, hearing aid often does not offer the best representation of real sounds. it often misses many frequencies. Many users complain that the equalization on them is made only for listening to speech, simplifying and often ruining the experience of hearing other things like music. Has there been any progress in research and new technologies with better hearing aids?
Yeah, so there is a lot of research being conducted. And there are a lot of researchers and heavy companies that are behind all those hearing instruments, as they call them. One thing that you have to remember is that really the damaged cochlea, so the inner ear, once it's damaged, has a couple of unique features. And the first one that you know is that the threshold of hearing is elevated, right? You don't hear those very faint noises and low levels. But what you know is that the threshold of pain, so the maximum level you can hear, did not change. So what happens is that you're moving your floor noise or your floor and the top, and you're just moving the floor up. So now you have a limited bandwidth and dynamic bandwidth. So you understand that from the audio processing aspect. And what happens as well is that in terms of frequency sensitivity, you lose those high frequency first. This is how presbyacucy is happening. And you'll be actually using now a reduced frequency window. So now you have both the dynamic and the frequency range that have been reduced. And now you're asking me to pass the same amount of information, which is a musical piece or a score, through that narrowed pipe. That obviously doesn't work. Worse than that, the damaged cochlea has really lost its ability to discriminate in between frequencies. And this is very important because you understand that the ear is a filter, a comb filter. It has what we call cochlear filters that are really tuned to different frequencies. And those shapes are really, really sharp. But as the cochlea is damaged, those shapes are widening. And now you have an ear that is not discriminating just one frequency, but a whole frequency range. And no wonder that when you do have noise and speech, well, somebody with a damaged cochlea, somebody with hearing loss, and even a hearing aid won't be able to discriminate speech from noise, will be really handicapped because of that overlapping, the fact of their lack of resolution in the cochlear filters frequency. So those are really, things that you cannot really change, unfortunately. But there is a lot of research, as I said, and the idea to really narrow down to start what you need to pass. So now, you are affected with a hearing loss. Well, understanding speech is really key because speech is what connects us. We are connected through speech and a little bit of visual, but this is key. So I don't want to lose that aspect of speech, and I don't care for your ambient noise environment. And passing speech may be that in the hearing aid, I will now focus using some beamforming microphones, directional microphone, cardioid microphone, beamforming on the person in front of me because I want to understand that person. And any gain I do in signal to noise ratio is a huge help for my damaged cochlea. So that's this kind of microphone instrumentation. You can obviously remove the noise and all those artifacts from the speech you want to understand. Here, the machine learning is really helping a lot because there is indeed a lot of processing that can be done, at least on powerful computers. One of the questions is how can you really implement that on a small DSP, digital signal processor chip, with a reasonable power consumption. But there are, let's say, many avenues. And, the ultimate goal of those, companies, and, 5 companies are maybe owning 90% of the market. I don't have the exact figures, but that's ballpark the values, is really to have what we call the cognitive control of the hearing aid. So the idea is that hearing aid nowadays, with their digital processors, the microphones I mentioned, and so on, are able to really pick up speech. This is good, but let's say that you have 3 people in front of you. Which one would you be paying attention to? And you can only listen to one for the reasons I mentioned before. So one of the ideas is that we tap into what we call the efferent system. So the system that feeds back the ear from the upper cortex. And we actually say to the hearing aid which stream of audio information we're interested in. So this is an idea you can be locked on a source and get rid of the others, which is a little bit futuristic, but that's the holy grail of hearing aids, as we say. So we call that cognitive control of hearing aids.
Wow, that's amazing. I never heard any of that, especially like the using beamforming. Like, wow, I never thought about that, but it's true. That would be a way of focusing hearing on one subject. Mm-hmm. That's amazing.
As long as the person is in front of you, right?
Yeah, exactly. So here we have another one, and this is related to people like me, more like the audio engineering world. So how often would or should audio engineers get an audiogram of the ears, and how should they consider these findings into their workflow? Would you recommend applying DSP in their monitoring, like equalization, to compensate for the areas in their hearing that are missing sensitivity?
Yeah, so the first of all, the audiogram is a very, very basic and antique, test in terms of hearing sensitivity. And there's even the trend nowadays to say that there are maybe even hidden hearing loss, in the sense that people with normal audiograms could actually still be suffering from hearing loss. And you will see that actually exactly in the situation I was describing, is that they are not very good at discriminating speech in noisy environments. So audiogram is actually not a very good, storyteller for that reason. But worse than that, the audiogram is in a sense useless, because it tells you after the fact how your hearing is. And so it will be basically documenting, for example, that you have a hearing loss. It's not telling you, well, be careful, Mariana, you are overexposed. So it doesn't prevent, it's not a predictor in any sense. So you'd be just documenting, years after years that your hearing is damaging, and you don't know exactly from what exposure or what situation and so on, which is, I think, bad. So to answer your question, in the occupational health and safety world where I'm coming from, it's recommended by all standards and regulations that workers be tested every year, so once annually. So I would say, well, you should at least go to the, for a screening test or a full-blown audio test, audiological test, at least once a year. But I would say maybe you could opt for other tests than audiograms. So just testing your threshold of hearing is not sufficient for the reason I told you. And there are other more sensitive or more sensible, accurate, let's say, measurements, like what we call the autoacoustic emissions. So autoacoustic emissions are a response that your inner ear has when it's being sent two signals. So this is a little bit of a funny, I'll give you the funny explanation. You send basically an F1 frequency, a pure tone, beep, another one F2, so beep. And then what will happen is that those tones propagate through the ear and inside the cochlea. And here there is a cochlear amplifier that actually amplifies those sounds mechanically. But by doing so, it creates what you know as being intermodulation distortion, which is something you try to avoid in your mix, I guess. But here it happens. And that F3 frequency, which is exactly 2F1 minus F2, will happen. So it's happening at a very known frequency, F3. And it's a very faint signal, which is that comes back and travels back to the ear. So if you have a very sensitive microphone, you can record that F3. After you send the two tones, F1, F2 together, you record F3. And this is what we call the distortion product in the autoacoustic emission world. And from that F3, you know that, well, the cochlea is working and there is all this cochlear amplifier that works well. And this is actually a test that is being used nowadays more and more in Canada for the newborns. So if you want to make sure that the peripheral system of a newborn is functional, you don't have to have an audiogram and have the newborn raise the hand. It won't happen. So what you do is you use those probes. This is really a clinical setup, and you assess if the ear is functional. So that only works and assess the peripheral system, doesn't tell you that it's properly wired and connected. There may be other issues, but at least that's a quick test, and that will diagnose things before the acquisition of language and all the development of a normal kid. So that's very useful, and it's it's now used more and more in the occupational world. We see autoacoustic emissions be used as an early indicator of a hearing loss and to prevent hearing loss. So I can see, you may be overexposed, and then I could see, okay, what is causing this and reducing the source. So for you, in practice, I would, and recommend to all you and your colleagues to try to find, some good clinical audiologists that do have access to OAE, autoacoustic emissions tools, and to just track that years after years, because there is no normative data. We can't tell, okay, this is a good hearing, or this is not a good hearing. OAE are very personal, but one thing we know is that they are relative to you. So if you have a baseline and you move from that baseline, this is an indication that, well, maybe there is something wrong with you, and this is a very good and early indicator.
This is how I record an acoustic guitar. If you have any ideas for future episodes, let me know in the comments. Let's get to it. I like a simple one microphone pickup for an acoustic guitar. No need to overcomplicate things. I will use almost any cardioid pencil condenser microphone, but I have to say that my secret weapon is the AKG C460B. The sweet spot on most acoustic guitars is the 12th fret. Place the microphone 4 to 6 inches away from the instrument with a slight angle towards the sound hole. If the microphone gets too close to the sound hole, the guitar will start to sound boomy. And if you move the microphone too far away from the instrument, the sound will get thin. But of course, you should experiment and find the position that works best for the guitar you are recording. To recap, for good results, keep it simple. A single cardioid pattern pencil microphone placed near the 12th fret will get good results almost every time.
The Audio Engineering Society is all about community. It creates opportunities for its members to travel across the globe, meet like-minded people, share amazing experiences, and make friends. AES members all around the world enjoy being part of the greatest network of audio professionals, scientists, educators, and students who want to learn from each other and collaborate to explore the world of audio. The AES wants its members to grow both personally and professionally, and in particular it seeks to educate future generations of audio professionals. It's not a secret, though, that being a student is really expensive. Educational resources, tuition fees, and the tools that are required to learn the art, craft, and science of audio can quickly drain one's wallet. This is why the AES has started collaborating with some of the most renowned audio companies out there to create the all-new Student Member Benefits program. This program delivers immediate value to all AES student members in the form of software, services, and educational resources worth multiples of the membership fees. If you're a student member already, these benefits are available to you right now. Should you not be a member yet, now is the best time for any student to join. We'll be adding more benefits in the future to create a steady flow of fresh content, so keep checking our website and social media outlets for the latest info. We would absolutely love to see you at future conventions and local events, so throw yourself out there and get involved. You will not regret it.
Hello everyone, my name is Jesse Lawrence, and I'm joined by my crewmates, Kyle Blazig, Connor Gokul, and Gabriel Packer. And we are all students at the Ontario Institute of Audio Recording Technology, located in London, Ontario.
Today we would like to present our most recent academic endeavor, our recording project for our music production class.
The project is called Rise Up, which is a modern folk song written by myself and mixed and produced by the entire crew.
Our school OIART is located in London, Ontario, and is an accelerated course consisting of a dense 11 months and 1,300 hours of learning, 650 of which are hands-on. The program starts in September of every year and ends the following July, and with a maximum enrollment of 68 students per year, every student receives a unique experience, unlike many other audio recording schools. This year, our class size is even smaller due to the COVID-19 pandemic, translating to even more access to the program facility and faculty.
OIART does not specialize in strictly music production. On top of exploring music production, every student in the course explores a variety of audio-related material, such as live sound and event production, audio for visual media, room acoustics, and Pro Tools.
The project we are presenting today was a part of our music production class and was worth 30% of our Semester 2 Term 1 mark. Our task was to produce, record, and mix a piece of music. We were given 27 hours over 5 weeks to complete this project, and it was required for the project to be 50% acoustically recorded. Due to the genre of our song, we ended up recording closer to 95% of our project acoustically. It was upon us four to find talent for the project, and due to the current pandemic situation, we figured it would be safer and more efficient to have one of our own crew members, Kyle, perform on the project. We were required to submit a Pro Tools session of our project as well as a full production report for our song.
Before each of our studio sessions, we would all meet up as a crew and make a plan for who would have what roles during the session, what mics we would be using, and what we would try to accomplish in the studio that day. We would look at our notes taken in class and directly apply that to our sessions, like using certain microphones and stereo miking techniques on instruments and utilizing the outboard analog gear and console for our recordings. We gave ourselves a challenge in the pre-production phase of our project to run as many instruments as we could through the Neve 1073 preamps that we have at the school. We did the most we could with 2 preamps, but some instruments, such as the drums, couldn't be put through the 1073s. We recorded those to the Avid C24, not an analog console.
So here are a couple screenshots of our production report for our recording sessions. As you can see, we tried to plan as much as we could beforehand to save us valuable time in the studio. We created studio floor maps for each session, mic lists, and role assignments for each crew member to avoid any possible issues regarding decision making during sessions.
As stated before, we really tried to utilize what we learned in class and apply it to our project to get the best possible sound. On the left, you can see we tried to mix both the condenser and the dynamic mic on this bass amp. We thought that the Neumann U87 would cover the clarity side of the bass, while the Shure Beta 52 would ensure the low end was where we wanted it to be. In the middle, you can see we used a Glyn Johns miking variant on our drums. We used a top mic, a side mic, a kick mic, snare mic, and a room mic to achieve the sound we wanted. On the far right, we have our acoustic guitar setup, 2 Royer R122s set up in a Blumline stereo technique. We ended up running these 2 through the 1073s and got a really warm sound that we were all happy with.
In the control room, we had to combine our knowledge as a crew to problem solve and understand the studio's signal flow to get the job done. As stated earlier, we were either recording through an Audient ASP8024 or an Avid C24. When recording on the Audient, we took it upon ourselves to enhance our sounds by patching to the studio's outboard gear as much as possible. We sent many instruments through the Neve 1073s and used other outboard gear such as an SSL G384 bus compressor, the Empirical Labs Distressor, and the Teletronics LA2A. Because of our use of outboard gear, we were all very comfortable with the console signal flow and patching by the end of our recording process.
As per the project guidelines, it was required that our crew makes a full production report, detailing everything that went into making the project. Here are a couple screenshots of our production report that we made. It goes over the song's chord structure, preamp settings, mic placements, and effects used on sounds. A copy of this production report will be available via download link on the Toronto AES website.
For the rest of the semester, we will be going over mixing in depth and will individually be remixing this project with the new knowledge we will gain. We are also in the early stages for another production project which will be due in the 2nd or 3rd week of April.
Overall, this project taught us a lot about the music recording process and solidified our knowledge of recording technology up to this point in our program. We learned how to manage our time wisely and be as efficient as possible when in the studio. A current bounce of Rise Up by Kyle Blazek is available for download via the Toronto AES website. Thank you.
And I cannot see you, and I cannot pretend, and I cannot.
Hi, I'm Ofer Weiss, and I'm from Toronto, Ontario. I'm currently studying media production, and I'm in my 3rd year at Ryerson University. The following video is going to explain a bit about the project, but I hope you enjoy, and thank you for watching. My name is Ofer Weiss, and this is my audio project, Jungle Song. First I'll play a bit of the song, and then walk through some of the techniques I used to make it, but before all that, just a bit of background. Jungle Song is a project that I worked on over 2 different courses at Ryerson University. It began as an assignment for a class called Sound Synthesis, the goal of which was to learn about synthesizers and audio editing techniques. I chose to make a song set within a jungle, where the listener is surrounded by animals and jungle ambience. I also recorded instruments in my room to create melodies, bass lines, and percussive elements. There may be no vocal performance, but I think that the animal sounds are enough to provide a strong life to the song. The class ended and the song was done, but this year I took an immersive audio class. It was in this class that I took the stems from my previous project and mixed the song into 5.1 surround sound. I'll now play a binaural mixdown of a part of the song. For best results, please put on your headphones. So I hope you enjoyed that. Here we are in Reaper, the DAW that I used to create the surround mix. Keep in mind that all these stems are taken right out of Ableton Live. A base layer of ambience tracks provides the immersion of being in a jungle. These tracks include rain, insects, and a general ambience track. They are all panned wide left and right across different levels, as well as mixed through reverb to provide a very wide ambience. The instrumentation was all done by myself in Ableton Live using my electric guitar, bass guitar, and Korg Mini-Log synthesizer. Let's play some of these tracks on their own. Here we have the underlying drum groove. And here we can hear the synth chords under everything. Here we have the bass guitar. In this passage, we can hear a mix of guitar palm muting and a Kodo-style synthesizer. All the amp effect and EQing was done in Ableton Live, and Reaper was used to pan the instruments creatively to give a diverse array of sounds. The only static elements are the chords and bass line. The rest of the song is composed of various animal sounds that I sourced from our school's audio library Access. These include many birds, jaguars, monkeys, and pigs. So the editing for timing was done in Ableton, but once I brought these sounds into Reaper, I mixed them with automation to switch locations each time they played. This resulted in a disorienting but immersive experience, hearing many different animal sounds all crying out around you. So I hope you enjoyed this look into my Project Jungle song. It has shown me the possibilities of surround mixing and how it can create a truly immersive audio experience for any application. Thanks for listening.
Hello, Roberto.
Hello, Anthony.
Have I got you there? Looks like you're in the building right now.
Yes, I am.
You're in 40? Are you in 40?
42.
Oh, 42.
Yes,
Sorry.
42.
They the same console, so I didn't know. It looks the same, right? So, Roberto, thank you very much for joining us. I know you're a busy person today. You got stuff going on, obviously. So let's cut to the chase and let's talk about you. You're producer, recording engineer at CBC Studios. What's that all about?
I'm basically a senior mixer engineer for the television side here. So I do a variety of different things like Olympics, done hockey night. I did the federal debate, the election here.
Yeah. What are you working on today? What's going on today in the building?
I'm helping out with the Polaris Awards down in Studio 211. It's just live. Well, not as live. Everything's a little bit different these days, but it'll be like one performance later today for a live music awards, the new artists.
Very cool. Very cool. Well, we can't give that away, right? It's a award show. We can't talk too much about that. But so in the recording side, Roberto, as a producer, you have somewhat of a live performance aspect to your mixing duties, because you also are heavily involved with decision making of music tracks. So how does the recording background you have lend to the mixing skills that you now use in some of these shows that you've got on your plate?
Years ago, I never thought it would have had this kind of effect, but it really does. My background, learning to do things in music and being able to layer and combine everything together, the principles of, certain things have to stand out, push out, other elements have to push to the background. That falls completely in the same realm, whether you're doing, when I was in post, I did a lot of effects editing or a lot of effects on live sports. How you're trying to get something to jump through and into the background, pushing music underneath. You're still trying to orchestrate, if you will, and combine everything in an effective manner that meets production's goals of how they want the show to feel. That's kind of interesting. You just can't make everything louder. Right. Different than making everything louder in a band mix. You have to decide what that focus of the mix is going to be, and that really is quite apparent when you're mixing these kinds of shows too.
Well, the second to the the ambience, like there's almost like a dramatic element to the music that is in these productions. So where does this music come from? Does the production contract, is this all unique music, or is this in-house, or how do they get this stuff?
Well, there's a variety of, sometimes, like say for the Olympics, there will be a composer that does the main overall theme, and there'll be different variations of that theme. But when you're live on the air, and we were basically 24 hours a day, you can't run the same cuts every 10 minutes. And then there's library music. A lot of ours is from APM that's selected. So sometimes production they'll select, here's our 100 bass cuts. It'll come to us, and we'll edit them for the start points. We might say, we want to make a loop here. And then as we're going in the Olympics, the production doesn't want to look for more cuts. So a lot of times I would just get on the library and look for things that I thought we were kind of missing. Like, I found that we had overused some of our dramatic elements. And so you're just looking for something else that would kind of work, depending on the stories that are coming along. And that is, what's happening in the Olympics, for example, story-wise. Is there something sad coming, or is it like basketball, which would require a different kind of music that would just seem like more in tune with that sport? And then you just go see if you can find it. First of all, it's not that easy to find, and then drop it in. And it's also good to just across 2 or 3 weeks to introduce new things bit by bit. What I would also do is that a lot of this music is 3-4 minutes, but we may only use 10 or 15 seconds. So a few days in, I'll just cue in and look for another endpoint that might work,
right. You're jumping around the music. You're doing a Beatles where you chop up the tape, you throw it up in the air, and you pick a loop that works.
Yeah, so we don't sound the same. We can try to sound newer. Because we can't have 1,000 cuts. Yeah. So we try to look for different things and look for things that kind of work and match where you're going to.
When you're bringing them back, are these,
for example,
are these stereo clips, or are these surround clips that you're bringing in?
Actually, I found, even when I was in post, a lot of things that were composed for hockey, for Olympics, the 5.1 mix was usually an upmax version. It wasn't really true 5.1. So, and a lot of our library stuff is stereo. So we're upmaxing it. Our Apollos, a lot of our suites, but our Apollos have Waves, Mercury, and the DTS bundles. So we're using one of the upmax versions and moving it to 5.1.
Right. Well, and like you say, 5.1 is all of these consoles. You're not dealing like an input, like a fader is not mono anymore. It's a stereo thing, or it might be even a 5.1 fader. Like, tell us more about this thing that's behind you, and how it's changed the game from I don't want to say the old way of doing it, of like being at the venue with the console, but how is this, now that you're a remote venue, just a huge router, and for those 5.1, for those stereo things, for those intercom things, what is that all about?
Well, the Apollo, for those who don't know, is very helpful for us. In the old days, we'd had multiple consoles around us. The Calric Apollo's got about 1,100 inputs, several hundred outputs. We'll push it, but we haven't maxed out on Olympics yet. And when you have so many 5.1 sources, we have to mix between sources. So we might be at track and field, for example. We'll be killing the center channel and leaving the ambience up from track and field, then opening up another dialogue from the host or from somewhere else, and then crossfading the 5.1 ambiences at a different point in time. So you're not going to go from one fader to the second. You're mixing basically stems underneath and at different points of time. And then you're rolling music in and out and maybe different ambiences. So on a console with basically 2 layers of faders, it's very handy to visually organize yourself. So there's so many different ways of doing it. But how we've done this recently is that we would put on the lower faders basically all the ambience of that venue, and the upper smaller fader, the dialogue from that venue. And so you can visually see, I'm going to go from this I'm going to go from this venue, leave my ambience up, kill the audio, and then move over. And now you can visually keep track of what you're doing. Because a lot of things happen very quickly, and you could get lost, bring up the wrong ambience or the wrong announcers. You're not, there isn't a lot of time to check. So you have to trust your setup and go right to where you're going next and hit your levels.
Okay, so then maybe, I think maybe one of our other presenters will speak a little bit about this, but when you say venue, like you're not dealing with one venue at a time, you're dealing with multiple venues, and while you're on the air live with some venues, you're recording in post-production on other venues. There's parallel workflows. So during the Olympics, how many venues are in play at once? And is that for all of the broadcast, and it gets shuffled to post-production? Could you explain a little bit about how much television is being produced, I guess, simultaneously?
Sure, it's. Like, for example, on my screens, we'll put up about 18, up to like 17 or 18 venues at one point in time, and those venues will change during the day. But that's not all the venues in the Olympics. So we could have edit suites who are recording, say, for example, skateboarding is on. CBC on air, main air net is not going to show skateboarding till later, but we have an edit suite that's recording it, and they might be streaming it at the same time. And at that point in time, because of COVID, most of our voice announcers were here in booths in Studio 40. So all that stuff is passing through the console. 14 basically announced booths were in there, and that's passing through these consoles, their monitors, their mics, their talkbacks, and that's hitting edit suites. And from edit suites, they might package something in post-production, and we might see that as a package to be played back later in the day. But all events are streamed at the same time, and we might dip into and simulcast a stream here on the main net, and then go away from it. But streaming allows you to watch it all the time. So simultaneously, I can't even tell you. We could be running well over 20, 30 events at the same time, depending. It just basically depends on what our capacity is for our stream, for our switches and our streams that are coming through.
So when the operator's sitting there, they have underneath them, I guess there's like running programs in the background, running mixes. There's pass-throughs. Are they pass-throughs that are happening while the mixer's mixing in a live-to-air show? It sounds so layered and complicated, Roberto. I'm just trying to dig it out, trying to pull it apart.
Well, OBS, so Olympic Broadcast System, they generate a mix for each venue that's in 5.1 or Atmos for those who take Atmos. We do not. And that comes to us, and then we embed our announcers, or sometimes we'll buy an OBS version of announcers. And that basically gets married in a central router. And then from there, the production people, they'll choose, we're broadcasting, A, B, and C. We're going to ignore D and E, but we'll stream D and E. So basically all the events are happening at the same time, and we're just basically switching between what's on air, what's going in the background, what's going to post. We have to monitor, even though we may not be working on something, we're taking care of issues that might arise. I'll take skateboarding. I'm not doing skateboarding, but we have sub mixers who are sub-mixing the voice-over booths, who are creating a stream of the audio. That happens constantly. And we have to watch our network, our Dante network. I wonder if I'm getting a little bit off topic here.
Oh,
but
no,
basically,
no, it's good.
Yeah. So, there's many different layers of happening. There's basically someone mixing voice booths of the shows that we are choosing to put announcers on.
Right.
And that happens underneath the Apollo, underneath the mix.
So it's pre-mixing. So it's a matter of teamwork. It's teamwork because so talk about just then maybe in my these pre-mixers. How many, and just off the top of your head, pre-mixers were working in concert to make this happen?
Okay. We did basically 2 10-hour shifts, 2 CalRec Brios, which would be attached to our CalRec network, and they would be among the 14 booths. So the consoles were mirrored so that we would not have any sort of weird juggling thing happening. So basically, Brio 1 and Brio 2. Brio 1 would decide, Brio 1 would do booth 1, 4, 7, and 8 for these events. And Brio 2 would do 2, 6, 8, 9 or something. And it doesn't matter, and that would change. So there's prep time in the booth. Booths have to be clean before anybody goes into them, and we have to test them. They have to be in their booth an hour before the venue goes to check everything. And then our Brio mixers would communicate with us if their booths were on the air live, or they would communicate with the edit suites, because the edit suites would sometimes take control of those booths for streaming. And we would tell them, like, even basic things like, you're not on the air, please don't talk, because one of our biggest problems is having things go on the air that aren't supposed to. Right. There are no commercials in streaming.
Yeah.
But
there's also there's you say there's conversations that have to happen, and maybe and we'll talk to Andrew a little bit about the conversations. So again, it's more about muting the things than it is bringing the things on the air. So you have a team that publishes that pushes these off, and you said edit suites are involved. So because of the Dante network, because of the Maddie network, like how do the edit suites get involved with the talking directly to the booths?
They talk directly through our intercom, and our intercom is really quite interconnected with the audio. So all of our intercom frames, like each studio has an intercom frame. The tape area, which is 2 floors below us, has intercom frame. Each of those frames have a Brooklyn 2 card. It's called an Omnio, and we're running MADI. Where some things, some paths are analog, but a lot of our communication for the Brios I was speaking to, that was basically all done on Dante. All the monitoring.
So
it's on the talk back.
So it's a handoff. So it's a lot of handoff. This person kind of pre-mixes, pre-massage, handoff. Pre-mix, pre-massage, handoff.
Yes.
Doesn't
that's
sound...
stuff that Andrew and I would have coordinated quite early on. We would decide, okay, to make this work, we're going to use MADI for these paths,
right,
and Dante for these paths. And sometimes the decisions are because we have no more room on one path, and you got to figure another way to get there.
Well, and that comes up to the variety of things. Like, it sounds like a big mix of technologies and yeah, big routing. It doesn't sound like a lot of EQing and compressing, like the traditional thing people think mixing consoles are used for. That's a for sure thing. Yeah.
That happens at the very, that happens more or less at the very end. There are problems on some of our feeds. There's problems with, announcers, mic position and stuff. And so there's a lot of corrective things that happen. So our Brios will comp and EQ everything because some of their work is going straight to air, just right. Their dialogue, and we have to do that here. We'll have problems with. We had a lot of problems this past Olympics with some of the venues, and we had to do a lot of corrective EQ, etc. But right. Yes, basically the last stage is not necessarily the primary function of the console anymore.
So with that noise, this, let's talk a little bit about the Olympics and some of the, we'll call them the production decisions of how it sounded. This year was a unique challenge. Leave it to Tokyo to be the quietest Olympics of all time. This year, like a lot of people, and you're one of the producers on the, you gave it that. This was silence, Roberto. So, what was unique, and what were some of the unique things about Tokyo 2020/2021 in terms of dealing with those venues and the sound of this Olympics?
Well, I'd be remiss if I didn't mention something new that we did. We only had announcers at 2 venues this year. This is the least we've ever sent. And it was at swimming and at track and field. And one of the features on our CalRex is to basically do remote DSP, which we could control from here. So basically we dropped an RP1 is as you know, Anthony, we dropped one at each venue, and each RP1 has basically IO and a variety of IO, AES, MADI, Dante, and then the announcers were basically connected to that box, and we could remote control their IFBs from here and the outputs. And we had basically 2 mixers here operating that DSP from touchscreens. We can also operate them from the consoles, but our consoles were tied up. Something that we're hoping to address later on. So that was completely new. Having everybody else here, we've never run 14 voiceover booths, but because of COVID and travel issues, this is what we had to do. So basically, our control room, the directors, producers, execs, they were all here. I'm sure Andrew will tell you we had to separate people in many different rooms. So we had to create a lot of other mini studios where other exec producers had to be and spread them all out. And of course, they all needed to monitor the 5.1. So we had to basically create multiple rooms that were control rooms, but with 5.1 monitoring so they could hear what was happening. And then communication between those people, not to cross into
the intercom talk. Oh, geez. Well, it sounds like a huge routing complexity. It sounds like a real-time performance of music and decision. You can't possibly think of all of the things, like it's live television. You got to make decisions on the fly. How does one train for that, Roberto? How do you become you, and how do you become comfortable with dealing with that type of complexity, and how do you build up to that type of complexity in terms of in terms of doing television production at this scale, what prepares somebody for this? And what prepares somebody for this?
Okay, I think the variety of different things I did really helped. Coming originally from, a music background where I did everything from orchestral, jazz, opera, pop, jazz, then into television. I've done a lot of different sports. You start off at smaller venues, and you learn a venue, you learn how to do hockey or how to do basketball. And I think my years in post really helped, because I think many things are very integrated. I did a lot of sound effects design, and it was sound design, and it allowed. It taught me really well how to layer things together. And I think you just gradually scale up, working on larger projects, simple hockey game. I did a lot of US splits. And then the projects just kind of gradually get bigger. And I think to sit here, it's very useful to have done all the roles. I was once an assistant. I understand what's on the other side of the floor. When I can speak with editors because I used to be one, and the ability to communicate with different people in different parts of the jobs, I think makes a big difference. And then when you work with production a lot, learning to listen to production and what they want, so they don't have to ask for everything. So being able to anticipate what production is going to want. So the producer, for example, producer director for well, there's several producers on the show, and they're all quite talented. But one in particular is one I did Hockey Night in Canada with, so the finals, etc. When you get to work with some people repeatedly, you can predict what they're going to want, and learning to pay attention to the content, where the content is going, and feeling the content and the story is really important, because then you can. You'll make choices that help the production, and without them having to call for absolutely everything they need. I think that's beneficial, because they can concentrate more on what they need to do. So whether it's comms and being able to make sure that they can communicate and get past their equipment, or if it's mixing, and the more that you can do to alleviate their work really helps you at this level.
I like how you said to help them get past their equipment, because they want to make television. Their job isn't to be an intercom specialist or a control panel wizard. Their job is to talk to that person at the push of a button. That's a tricky one. That's a very tricky one. This year, I want to talk about a fourth dimensional problem you and I kind of talked about, which was, now that you have all of these feeds coming in at different times with different, remote packages and remote kits and stuff like that, what are some of the new techniques that you're having to deal with to make these things line up with rigidity and look like it's cohesive in time and synchronization? What are some of the new challenges with graphics and remotes that have changed in the last little while for you in this fourth dimensional problem?
A lot of it is just timing synchronization. So on the Olympics, for example, I had something like 12 different master buses, each with a different delay, and you'd ask why. And when you see Scott Russell, our host, speaking to someone on a green screen in Tokyo, but it was virtual. It was done with a very heavily, it was like a virtual background. Well, that required a specific delay to time to the video, because obviously any video processing is going to create X amount of delay that audio must match. But there were so many different setups that they had, that different types of interviews, or, past couple of years, everyone will talk about Zoom and timing that. You have to basically build and match outputs to for that and delays. But when you do that, you can't delay your audio going to the other side, because then there'll be this gigantic pause before you hear an answer kind of like the old satellite days. So you want to pass your audio pre that bus master so that everyone can hear each other as fast as possible to reduce the delay. So now you're thinking your in-ear monitors, or your IFBs, as we'll call it in TV, has to happen at a certain time that's different than what you're putting to air. And so you have to be careful where you're busing all your different outputs, depending on what you're doing with all these delays. That happens now regularly in baseball, in hockey, when you see player tracking. We see the names on top of each player. That delay, I did that on the All-Star game. In the middle of the game, they would flip to that player tracking, but that was I think a 14 frame delay. So basically almost half a second. And now you're changing your tracking of your sound effects in your crowd by half a second.
Right.
And you're crossfading back and forth. And that's getting to GPIs and stuff. But yes, so you have to now be very conscious of all your paths. And this is beyond mixing. So, and you have to be organized in such a fashion that you can find things quickly if you have to change something or reroute something.
So you said
you can't have,
and so you're switching between things that are delayed to things that are happening in real time to things that are you're effectively like you're like Einstein. You're changing relativity in real time, Roberto. Wow. Okay, so we got to
and then you hope it doesn't drift.
Yes,
so that happens on Zoom calls, but hopefully not on this other stuff.
Okay, so we're bending space and time in audio across 12 mix buses. That's impressive. That's very incredible. That's actually very incredible. So graphics. Now that these graphics are driving the thing, I look at the Olympics and, there's elements that they fly in. You mentioned briefly GPI. That's not a common thing that people talk about. Could you talk about the importance of, video-driven audio and how that involves, those big consoles?
Yes. I'll give you. I first started using GPIs on stuff like auto resync because you can't keep track with following effects from one camera to another. You want your, the director will say camera 2, camera 3, and you might have mics associated with those cameras. But you can fire a GPI trigger, which would basically be something that opens your fader at that point in time. So the switcher will hit that camera. It fires an impulse that will basically open your fader, and there's a way to invert it to close it as well and basically open each one. And then you can actually assign a fade up time. So basically someone is controlling your console. I use it a lot for specific cameras, like on award shows. The reason why we use it is that you're doing so many different things, and if they're flying between 5 or 6 different cameras, or on the finals, I had 21 cameras on GPIs because there's entertainment cameras and things. And you want, that would be your sole job, but you can't make that your sole job. So I would assign all those to a master bus and ride one fader while all those mics went up and down.
Well, and it's somebody else is making that decision, right? Like that decision is already being made electronically, so you're piggybacking on that GPI. So GPI is a general purpose input, right? And you're right. It's just like somebody touches a switch and your console goes, hey, somebody touched a switch.
Yeah, and I just assign it to a master bus. Sometimes I want that source, and other times I don't. And you want to ride that level, so I assign all the outputs, a bus for all those GPIs. Just say one fader, where I just ride that fader.
Yeah.
And while they'll just fire away. By the way, on any of those sources, I also have a second repeated source if I want to open up that camera without the GPI. So now 2 instances of that camera, probably of that microphone, exist because you can't rely on this stuff. It doesn't always work the way you think it will. So you have to have a backup plan.
Well, and that's so. Speaking of backup plans, just briefly here, we got about a minute left. Roberto, you did the election. You did some stuff out in Gatineau. Did you have what else? What did you do for the Olympics this year, or the election this year? What was your role in the election this year?
Myself and someone from SRC, we did the federal debate. So, and we did it last time, leaders debate in Gatineau at the museum. So a big, cavernous, open, echoey gymnasium would be polite. We brought our, we have a lot of cedars to deal with excessive fan noise, reverberance, and we insert those on all the microphones to try to get control of the sound a little bit, so it's not so echoey, and you don't hear people when they're arguing over each other, which apparently they do during debates. You want it to be as intelligible as possible. So we had that, and we use new IP mobile. IP is a very big path, obviously, that we're pursuing here at CBC. There's been more IP in everything we did, but we used Dome's new IP mobile, and we ran like 22 external intercom panels, half on Arvon, half on Dante, switches everywhere. I think we ran one multi-cable for an area where we had, I think, 30 RF mics, 20 wireless intercom belt packs, a dozen wireless IPs, just so everything, a lot of it was on Dante, audio wise, on a separate network than the Dante, like within the truck that was attached to the intercom.
Just
so
scale.
Multiple network, multiple LANs.
Just scale. Just sounds like everything you do just scales up on a weekly basis. That's pretty much it.
Yeah, it seems to get a little bit more complicated. Nothing's gotten simpler.
Well, Roberto, thanks for your time. I appreciate you taking the time to visit it with us so very much.
Glad to be here. Hopefully I didn't make it more cloudy than it needed to be.
Oh, no. People, there's no clarity in this, but it's opportunity. I look at this as opportunity for people to learn from you as a mentor. Thank you, Roberto, for sharing so much. Appreciate it.
You're welcome.
Take care. For more information on the Toronto Audio Engineering Society, go to torontoaes.org. There you will find notifications on our upcoming events, past events, Masters of Audio, and our member showcase. The Toronto AES is brought to you by Solotech, Gare Audio, Sonotechnique, Bell Media, YSL Pro, Electrosonics Canada, BRTB, Global USS, Adamson, Lawo, avshop.ca, Q5X, and the executive team of the Toronto Audio Engineering Society.
How to record a snare drum. The snare drum, the center of your rock and roll mix. My microphone choice, the Shure SM57. I like it close, almost touching the rim, 1 or 2 inches away at the most. Aimed across the drum, so it hears the entire drum. I never aim the microphone down. I'm not a fan of bottom snare microphone setups, but sometimes it can be useful. Try a pencil condenser. I really like the Neumann KM84. Mimic the placement of the top microphone, but give it a few inches more space. Also, make sure they are directly above one another. Check the phase. Chances are you will need to reverse the phase of the bottom microphone. Mix the bottom snare mic in with the top snare mic to taste. And that's how you record a snare drum. If you like this video or have a suggestion for the next one, let me know in the comments. And don't forget to subscribe.
Hi, everybody. Well, it's January 2021, and the Toronto chapter of the AES is again having a virtual meeting, this time on microphones. Well, virtual meetings involve video, which is what you're looking at right now, and which is what I'm making right now. It's interesting when you look at video technique on YouTube. It's incredible to me how many of these videographers talk about the importance of good audio. It's a revelation, really. We always thought the video guys were kind of off in their own world, leaving us audio guys to run after them. But the fact of the matter is, videographers really talk about and teach. You can't make a good video. You can't have a good presentation without good audio. And right now, this audio is not very good.
Here we go. Notice the difference? Well, I'm not just talking about what it sounds like,
I'm talking about that. Why it sounds better. I'm wearing a DPA 4060. This is a small, miniature, omnidirectional microphone, and omnidirectional mics have a lot of advantages. But wait, there's more. Here we are with exactly the same setup, with the difference being I've changed the microphone. This is a 4080, and it's a directional mic. So very similar to the 4060 in size, fit, and function, but directional. And if directional microphones have their own challenges, one of them is handling noise. This is balanced off on this particular model with the clip that we're using, which is an isolating soft rubber clip. But you can hear the difference. You can hear that incrementally the amount of room goes down. The actual vocal character stays pretty similar, which is exactly what it's supposed to do. There's more, though. We've got another one for you. This time we're using another omnidirectional microphone. This is a DPA 6061 sub-miniature mic, only 3 millimeters in diameter. Can you see where it is? It's actually in a location that's classic. At the dawn of live theater, when wireless microphones were being used in very large numbers, and of course they still are, the subject of miking an actor was a very big deal. Actors, they didn't want the actors they didn't want to be able to see the microphones at all. And they did quite a bit of experimentation on location, where the microphone should actually be located, from the point of view of not being able to see it, from the point of view of not having to worry about costume changes. And they came up with putting the microphone on the forehead, sometimes visible, or sometimes buried in the hairline. Can you see where this microphone is? It is right on my hairline. Now, this serves as a little bit of practical introduction to omni versus directional lavalier mics on typical locations, buttoned right up on a speaker's or a talker's shirt, and then this one up in my hairline. And that's exactly what our guest today from DPA, Bo Brink, is going to talk about. There are 2 videos. One of them speaks about, just speech intelligibility and resonances, very interesting. The other one talks about microphone location, resonances. They both tie into each other. Each video is about 3.5 minutes long, and I hope you find them interesting and educational. Thanks for asking us to be part of this Toronto AES meeting, and stay well.
If you ever had problems understanding what's being said in a large reverberant room like a cathedral, or perhaps in a packed classroom with a loud background noise, then you know what it sounds like when the consonants are drowned. In this tutorial, I will explain why speech intelligibility goes down when the consonants drown. Speech consists of both vowel and consonant sounds. The vowels A, E, U are all generated by the vocal cords in our throat and filtered by the vocal cavities. The consonants are T, S, P, K, B, pretty much all the hard sounds. They are all created by air blockages and noise sounds, all formed in the passages of air through the throat and mouth, particularly the tongue and lips. When the vowels are identical, the consonants before or after the vowel makes the differentiations of the words. The vowel or doesn't mean anything, but if I add the P, it becomes paw, or the L, it becomes law, and then it makes sense. Like the words top, bob, pop, they are identical without the consonants. So, the consonants are extremely important for speech intelligibility. Without the consonants, we are not able to understand what's being said or sung. Even though the consonants are hard-sounding, they have very little energy compared to the vowels. It is impossible to add energy to the consonants. Try to yell the sound of a T. It's not louder, even though you are yelling it. This basically means that when you yell, the consonants are masked by the vowels. And you're not making it easier to understand what you just said. Consonants are predominantly found in the frequency range above 500 Hz. but most of them are in the area between 2 to 4 kilohertz. So this part of the frequency range is therefore one of the most important areas to preserve when focusing on speech intelligibility. Reflections, background noise, or music can easily mask or bury the consonants. Listen to this word. You can't really tell what is being said, but if I remove the reverb so you can hear it without the reflections, you will understand it. Mist. If the background sound or the reflections are too loud, it can often be solved just by moving the microphone closer to the mouth or by changing to a mic with a more directional characteristic. So the takeaway from this tutorial should be that in order to maintain the high speech intelligibility, you have to preserve the consonants. And in order to preserve the consonants, there are 3 easy steps. Choose microphones with a wide frequency range, place it close to the sound source, avoid as many reflections and as much background noise as possible. Why is it that we have to have eye contact when we are talking to someone? Does it really add to the speech intelligibility? Well, you can sense the mood and more of the meaning of the conversation if you have eye contact, but the acoustics of the voice is also a very important factor. The level of the speech is much higher in front of a person, but the intelligibility is also much higher. This is due to the content of the frequencies in front of the person talking as opposed to behind the person. In this diagram, we see the blue line representing the high frequencies and the red line representing the lows. The green line are the mids. High frequencies are only radiated in front of the person. And these high frequencies add to the speech intelligibility, and without them, we compromise the meaning of the message. If we look at the vertical plane, we will also see a difference in the frequencies. There is a higher representation of the high mids in the 2 to 4 kilohertz area above the head. And this is very important to know, and this is where all the consonants are. In the following, we will hear the differences between the positions on a female singer. We use a common reference at 1 meter as our normal, because 1 meter is the normal distance for a conversation between 2 people. So compared to the reference 1 meter away, a placement on the forehead is close to identical. The forehead position sounds like this.
I used to feel so uninspired.
If we move the microphone backwards to the position just in front of the ear, we see that we then lose a lot of the high frequencies. It sounds like this.
I used to feel so uninspired.
Next position is the headset position. It's not as far behind the mouth as the ear position, so the high mids in the 2 to 3 kilohertz range are not as attenuated as before.
I used to feel so uninspired.
There's a bit more of the mid-range, where the consonants are predominant, so there are many good reasons to use the headset position, but it is still lacking a bit of the speech intelligibility compared to the forehead position. The next position is the typical lavalier position on the chest, which introduces a few challenges. One challenge is that the level of the direct sound of the voice is much lower than on the headset position, and we therefore pick up much more background noise. And frequency-wise, we lose not only the high frequencies, but much more in the mid-range, again compromising the speech intelligibility.
I used to feel so uninspired.
And again, hear all 4 positions without me interrupting in between.
I used to feel so uninspired. I used to feel so uninspired. I used to feel so uninspired. I used to feel so uninspired.
So, in order to preserve the natural sound of the voice when you are forced to place the microphone in a less than optimal position, like on the chest, you have to compensate with an EQ. You can use these basic graphs for inspiration to compensation. But this will only work for you if you are working with a microphone with a frequency response you already know. If you don't know the frequency response of the microphone you're working with and you follow these common rules, there is a huge risk that you're doing more damage than good for the sound. Microphones with a high degree of consistency might be a little more expensive, but it pays off tenfold in post-production.
All right, everyone. Thanks for those who stuck around and watched our year in review. There's a lot of different, meetings that we're part of, different topics that we like to explore as an organization. Wanted to wish everyone, thank you for participating. Wish them good health in the new year, in the upcoming holiday season. Good luck to all those who are out, performing, doing gigs this holiday season. Take care, everyone. Thank you for sticking around, and enjoy the rest of our collection. Please go to torontoaes.org for more links, as well as connections to all of our previous content. Have a great night. Take care.